We're studying quadratic functions, and we're going to begin by looking at properties of quadratic functions. First of all, we use the f of x notation to denote a function, which is the same thing as y. And for a quadratic function, the form is ax squared bx and c. It's called general form. A can't be 0. You can think about why that would be. A, b, and c represent real numbers. And if we graph it, the graph has the name parabola, has a certain U shape that we're going to see. A quadratic always has degree 2 term. It may have other terms, and those terms will have whole numbered exponents. To start, let's graph a couple of functions together. I've made a list of functions, and we're going to use our graphing calculator to graph them, and then we're going to observe the properties, direction of opening and intercepts where it crosses the axes. So I get my calculator out, and I've done something to help with efficiency. The equations I wanted to graph are x squared, 2x, and 0, x squared, 2x, and 1, x squared, 2x, and 2. So this set notation allows me to graph all three of them together, one after the other. Here's the other graph, negative x squared, 2x, and 1. Now, for a lot of graphs near the origin, zoom 4 is an effective window to see things. There's our first graph, second graph, third graph, and that's the fourth graph. Now, I'm going to copy this and put this into our notes, and then I want to comment about it a little bit. So let me grab that image. Try to grab that image. Bear with me while I grab this image. There we are. And I'm going to resize it a bit so we can see a little more clearly what's happening. All right. So the graphs, this was the first one, the second one, the third one, and this was the fourth one in our list. I'll number these as well. 1, 2, 3, 4. There we go. So notice, first of all, they all have y-intercepts. All parabolas cross the y-axis. That's where x is 0. Does that make sense? We're talking about substituting 0 into these equations. By the way, the x-intercept then is that c number on the end. So 0, 1, 2, and this one looks like 3. Let's see, we also get movement up or down. We're going to study that more later. The x-intercepts. This particular parabola has 2 x-intercepts. The one above it only has 1 x-intercept. It only contacts at that one place called a vertex. And this next one has no x-intercepts at all. So that's an important observation. You can get varying results for the x-intercepts. The fourth one is different than the other three. You'll notice that the direction of opening is that it opens downward. The fourth one has a negative sign. That's why. We'll study that more as well. So let's summarize some properties. The direction of opening, well, it's up if the a value is positive. It's down if the a value is negative. You could study some more examples on your calculator to verify that. The y-intercept is defined as the place where the x value is 0. So therefore, it's at 0, comma c in that general form. C from ax squared, bx, and c. The x-intercept, by definition, is where the y is 0. So we solve the equation 0 equals ax squared, bx, and c. And hopefully it factors, otherwise we're going to need another tool. Axis of symmetry. That's something I didn't comment about. An axis is a line that shows where the symmetry is. And if I go back up to the graph, we can see that there's a vertical line. There's a vertical line, and what's to the left and to the right behave identical. Now, the equation of a vertical line, I should jot in here, vertical line showing symmetry. Vertical line equations are x equals a number because x doesn't change when you move a line up and down. Domain values. Domain are the x values. Well, there's no restrictions, so x represents all real numbers. There are no undefined values, no restrictions, no problems with any numbers that we could put in. The range. range of the y values. Y is either greater than or equal to some number n, or it's less than equal to some number n when the vertex is x comma n. Notice how I use the same number n. Now, the vertex is the turning point on the graph. It's the place where it stops going down and starts going back up. So here, here, here. And this one is going up and it stops and starts going back down. The vertex is over here. The vertex represents either the lowest place you can go on these three graphs, that's the lowest it goes and it's always up from there, or the highest place you can be and therefore you're always down from there. If you're the highest place, it's called a max. If you're the lowest place, it's called a min. And it connects to the direction of opening. So I'm going to get a minimum value when I open upward, and I'm going to get a maximum value when I open downward. You may want to pause and go study those videos a little bit to make sure that you understand that. Now I'd like to work through a couple of examples with you to show how to use this information. First example, x squared minus 4x. We can see we have a quadratic because of degree 2. I'd like you to graph it, and I want you to find all of these features. You may want to pause right now, grab your graphing calculator and try it, and then rejoin me. Okay, I'm assuming that you've given it a try. I'm going to my graphing calculator. I'm going to disable the graphs that we did before by just turning the equal signs off. And I want to graph x squared, and I believe I said minus 4x. And I'll choose graph. And there we go. Okay, so we can see we have two x-intercepts, and this x-intercept is also the y-intercept. My vertex is somewhere right down here, just off the graph, and there's my axis of symmetry. Okay, my vertex, well, I should go back to the graphing calculator and find out exactly where it was. It was 2 units to the right, and 1, 2, 3, it's going to be 4 units down. Now, we have a way to verify that in a minute. 2 units to the right, 4 units down. The axis is an x equals equation, and it's the same x value. And I'll just make a note that the vertex is on the axis. Here's where x is 2. Make a little imaginary line to help me visualize it. The y-intercept is at 0, 0. Remember, that's when x is 0. Term becomes 0, that term becomes 0. Well, this x-intercept is also the y-intercept. And there's another point. And here's an idea. I'm going to factor this. X minus 4. The x-intercept is when y equals 0. So imagine solving this. One value would be 0, one value would be 4. And we saw that visually on the graphing calculator. There are my two x-intercepts. This one's also a y-intercept. Domain is x values. They are all reals. Now this wasn't opening up, so it has a minimum value. Now, if I wanted to be sure of where the vertex was, I substitute 2 into the equation. 2 squared, that's 4, minus 4 times 2, which is negative 8. 4 minus 8, yes, it is negative 4. So let's plot that right there. And this is the shape of my graph. Reasonably good sketch of it there. And put little arrows to indicate that it keeps going upward from here. The range, then, is a y value that's more than or equal to negative 4. It matches that point on the vertex. Another example. Find the intercepts and axis of symmetry, rather, for this function. Well, one thing I can do with this function is I can factor it. They don't all factor, but in this set of exercises, most of the time they will. The x-intercepts are where y is 0, so I'm essentially solving an equation with a couple of factors. We've seen this before. X equals 4 or negative 2, and to write them as points, what I mean is 4 comma 0 and negative 2 comma 0. There's my x-intercepts. My y-intercepts, remember, that's where x is 0. So I say y equals 0 minus 8. So it is 0, comma, negative 8. Remember, that c value, that's your y-intercept. One more thing, the axis, let's look back at a previous example. The axis is right in the middle. It's a line of symmetry. It's right in the middle of all sets of points, and what you see on the left, you see on the right, behaving the same way. Notice these x-intercepts, how they were 2 units away, 2 units away. What it suggests is, if I know the intercepts, the average or mean of them is where I'll find that axis. Let's use that. I'll use the x of 4, and I'll use the other x value of negative 2 from my x-intercepts, and I will average them. 4 plus negative 2 is 2. Divide by 2 is 1. So x equals 1 is my axis of symmetry. And therefore, I know my vertex will be at 1, comma, y value. Put 1 into the equation. 1 squared minus 2, that's negative 1, minus 8, that's negative 9. That's a way to find vertex. Alright, one more example, and it has to do with the symmetry. Use symmetry to find a third point for a parabola that has vertex at 2, 3, let's plot that, and it passes through 4, negative 1. So I know these things. Now, I don't know the equation, but I can work visually and with symmetry. The vertex is on the axis of symmetry. So my axis of symmetry is right here at x equals 2, the same value as the x value of the vertex. By symmetry, I see that this is 2 units over. So by symmetry, there must be another point 2 units over for the same y value, right here. So my other point is right here at 0, negative 1. Alright, hopefully this is helpful for you in working through the problems.